So let's erase this stuff. And given the three matrices below, find x and y such that 2a plus b equals c. What's 2 times a? Look at A on page 659. What's 2 times A? 4, and then what? And 2x? And 6? And 2y? Is that right?
Oh, yeah. I was picturing going this way.
You were doing the more complicated stuff.
Yeah.
Okay. No, we're just taking 2 times each of them.
Right, okay.
And then plus b. And what's b? 2 negative 1. And what else? 3, 2. So let's add those together. And what do we get? 4 and 2 is 6. 4 and 2 is 6. 2x minus 1 is 2x minus 1, right? 6 and 3 is 9. And 2y and 2 is 2y plus 2. Everybody agree? Right? And what is that supposed to equal? And C is 6, 5 and 9, 10. Well, sure enough, we got the 6 and the 9, don't we? Now what do we have to figure out?
X and Y.
That 2x minus 1 has to equal 5. So 2x would equal 6, x would equal 3. Everybody follow that?
Yeah.
And 2y plus 2 would equal 10. So 2y plus 2 is 10. 2y is 8. Y is 4. X is 3, y is 4. How cool was that?
What did you do between this one and that one?
Between which one? This one and this one?
Yeah.
Okay, 6 equals 6, but what's my second term? 2x minus 1?
Uh-huh.
And that has to equal
5.
5.
Oh, because it has to equal 6.
Because it has to equal, because these have to be equal. So 2x minus 1 has to equal 5, and 2y plus 2 has to equal 10.
Okay.
So, problems 2 and 3, you've got A and you've got B, and they want you to add them. So look at the picture. You ready for me to erase this? Look at the picture and add those two matrices. What do you do when you add matrices? You add the corresponding parts. So what's my answer going to look like? You add 2 and negative 2 and you get what? 0. You add 0 and 1 and you get 1. You add 1 and 0 and you get 1. Everybody see what I'm doing?
Mm-hmm.
This is not rocket science, is it? It's just goofy math. You add 2 and 4 and you get 6. You add -1 and 3 and you get 2. And you add 3 and -2 and you get 1. You add 4 and 1 and you get 5. You add 1 and 2 and you get 3. And you add 2 and -1 and you get 1. And there you are. That's your answer. Well, that was easy enough. Number 3. 2a minus what?
3b.
3b. Okay. What's 2 times a?
4.
Yeah.
Yeah.
Let me put my chair up here and bring my book over here so I can look at it. So, a, if I take 2 times a, what do I get?
4.
4, 0, 2.
2.
Is that right?
Yep.
4,
Negative
-2, 6.
Yep.
8, 2, and 4. Everybody agree? Then if I take 3 times b, what do I get?
-6. 3.
I get -6, 3, and what else? Whoa, stay up there. -6, 3, and 0, and then what? What? 3 times 4 is
12. 9.
3 times 3 is 9,
-6.
and -6. And then what?
3. 6.
3 times 1 is 3, 3 times 2 is 6, and 3 times -1 is -6. Now what am I supposed to do with those 2 matrices? What's in between these 2?
A minus.
A minus sign. So let's subtract them. And what do I get? What's 4 minus -6?
10.
What's 0 minus 3?
-3.
And what's 2 minus 0?
2.
What's 4 minus 12?
-8.
What's -2 minus 9? And what's 6 minus -6?
12.
That's going to trip somebody up, isn't it?
Me.
Me too.
What's 8 minus 3?
5.
What's 2 minus 6?
-4.
And what's 4 minus -6?
-3.
See, that's why, remember, 4 minus -6 is 4 plus
Wait,
the
it would be
opposite
negative
of
It'd be
6.
-3 minus -3.
It's -3.
It's 4 minus -3.
This is -3?
Yeah.
Yeah.
I copied it down wrong?
Yeah.
Wow. That'll mess you up, won't it? 3 and 6 and -3. Oh man. So now we have 4 minus -3. What is that?
7.
7. And it could be that you need to do this. You need to go 4 minus -3 is 4 plus the opposite of 3.
Mm-hmm.
You might need to write it out so you don't make a mistake. All right. Number 4, to build 3 types of zigzag toys. They've got this chart here. What does this chart say? For type 1, it's what? 1211. For type 2, it's 1321. And for type 3, it's what? 4422. And what is this we're making? Frames, wheels, chains, and paint. You follow that?
Mm-hmm.
Now, and they want to build 20 of these and 25 of these and 10 of these, right?
Mm-hmm.
So how do I find out what I need? What do they want to know? What do I need? The number of frames, wheels, and chains. So how many frames do I need? Okay, watch this. I put this out here, and I go 20, 25, no, let's make it a little wider. 20, 25, and 10, and I take this matrix times this matrix. You see why? Because when I multiply this matrix times this matrix, I take this first one times the first column to get my answer down here. I'll change colors. So I need 20 of these. See what's going on? 25 of these and 10 of these. So what's that give me? 20 and 25 is 45 and 40 is 85. Everybody follow what's going on?
So you multiplied those by each one and then added it up?
So it's like I'm taking 20 times this, 25 times this, and 10 times this,
And then you added them?
and then you add those answers.
Okay.
Yeah,
Wait, 1, 3.
Wait, what do you add?
these three answers.
Oh.
And that's 40. So 20, 25, and 40 add up to 85.
So
And
you
see, that's called
multiply-
matrix multiplication. So that's why I wrote this matrix out here like this, in this order. Even though I've got them stacked up here because I wrote up here what I wanted. But if I write it in matrix multiplication form, then it's written out there like that. So it's that matrix times this matrix. So how many wheels do I need? Times 20
So
times 25.
What would you? I don't understand.
I'm going to make 20
You
of...
multiply the top row by 20, and the
Oh,
second
okay,
row.
no. I'm looking at the total frames that I need. What's the total frames?
Well, 85, but I don't know how you got 85.
Well, how many frames do I need for type 1? 20. How many for type 2? 25. How many for type 3? 10 times 4.
Okay.
That's why I said if you looked at it as a matrix multiplication problem, you would have this times this whole big matrix.
Okay.
So now how many wheels do I need?
So
How many total wheels do
you
I need?
add
20 times 2 is what?
40.
40. 3 times 25 is 75 and 40. So what's that add up to? 155? Is that right?
Yeah.
So now I need to take times 20 times 25 times 10 and get the total number of chains that I need. 20, 50, and 20. 90. And now I need how much total paint I need. Times 20, times 25, times 10. So we've got 20 and 25 and 20. 65.
Okay.
Now watch what happens next. For the next problem, it says, problem 5, frames cost $2. So frames cost, let me change colors here. See if red's going to work today. Frames cost $2. What else does it say? Wheels cost $1. Chains cost 75 cents, $0.75. And paint cost, where'd it go? 50 cents, $0.5. So now what do they want to know? Find the total cost for the 3 times. So what's the total cost for type 1, type 2, and type 3? So you figured out what happens? Now here, I had this 3 that I multiplied times each of these.
Mm-hmm.
So now I'm going to have 4 that I take each row, because I'm looking for a total here, each row times this column. And what's my column? 2, 1, 0.75, and 0.50. You follow that?
So now you're doing like type 1, type 2, and type 3?
That's right.
Okay.
So I'm multiplying this row times this column.
Okay.
So that row is 1, 2, 1, 1. You follow that? First row times my column, and then I add those answers. So that's 2, 2, 0.75, and 0.50. So the total comes up to be $5.25. See what I'm doing? Now that I've done that, can I erase this now? Because I have to do something else. Now what am I doing? I've done the first row. Now I do the second row, which is what? 1, 3, 2, and 1. So I have $2, $3, $1.50, and 50
$2
cents.
and $1.
What?
Oh.
Because I have 3 times this. Remember, I multiply these, and then I add the answers. So I have $5, $6.50, $7. So now I'm ready to do what? Yeah. See, I'm erasing this again, but don't have any more room to work. Boy, if my tablet worked in here, we could have all this on the tablet, just all strung out. So now I'm ready to do
So then you multiply the 2 to, or you.
the third row, which
So
is
then you
what?
just add
4,
these up.
4, 2, and 2.
The 4 numbers.
So that's $8, $4, $1.50, and $1. 12, 13, 14, 50. Cost $14.50 to make a type 3 toy, $7 to make a type 2, and $5.25 to make a type 1.
Oh, is that 2?
Is that right?
I thought that was a sign. Yeah, it's
Yeah, my penmanship's atrocious, isn't it? 525. Is that 525
Yeah.
supposed to be?
yeah.
Well, and can you see what happens the way this looks as matrix multiplication? Say, so that's like this matrix times, it's like this matrix times this matrix. See what I'm doing?
Mm-hmm.
Pretty cool stuff, isn't it? Well, I'm the only one that's smiling on this stuff. The rest of you are going, oh boy. Page 660. If A is this one and B is this one, calculate A times B. So do we need to go to the easy calculation to do that, or can we do that one manually?
Could probably do that manually.
Let's try it manually.
Just for fun. I like that. I like that. What a marvelous mathematical mentality. M&M. And see, that must be why I used to give away M&Ms as prizes. Marvelous mathematical mentality. That deserves some M&Ms. I should have brought some today. Just to make you feel better about doing all this ugly math. It's amazing how M&Ms make math taste better. So we have 4 and -5, and 1 and -1, and we're going to take this matrix times, what's it say? A times B, -1 and 5, and -1 and 4. So what do I do to get my answer? How do I find out what goes here? What goes here? I take the first row times the first column and add the answers. So 4 times -1 is -4. -5 times -1 is 5. Add that together and I get a 1. You follow that? Then what do I do to get the second number here? I take the first row times the second column. And 4 times 5 is 20. And -5 times 4 is -20. And I add that and I get 0. Then I say, what do I do for this one? And that's when I take the second row times the first column. And I get -1 and 1 and add them together and I get 0. And then to get the last one, I take the second row times the second column. And that gives me 5 and -4, and that comes out to be 1. You got that?
Wait, 5 and negative.
5 and -4, it comes out to be 1.
It's the identity.
Now for problem 7, where it says multiply.
Wait, we didn't do B times A.
What? Oh, you'll do that on your own.
Oh, okay.
Number 7, find A times B and B times A. Let's work B times A. So now I need to go to easycalculation.com, right? And punch in the numbers. And what is it I look for? Matrix multiplication. Let me turn this on. Matrix multiplication. Let's pop this up here. You got it?
Does it let you guys do it on your phone?
I have an app called Matrix,
Oh.
and it looks like this.
And it lets you do it?
And you input your matrix in it.
Because it has like this keypad, and I
It
can't
won't
put
let
a negative.
Me neither.
So I had to do it on my laptop, and I forgot. But I can't do it on here. I'll have to, what's that up?
It's called Matrix. But it doesn't do augmented matrix, like when we were trying to multiply them.
Are we ready? And if we're doing b times a, then what do we put up here for our first term? -2?
Just 2.
Oh, for B times?
Because we're doing b
For
times
b
a.
times-
1. And 0. 4, 3, and 2. 4, 3, and 2. And 1, 2, and -1. And copy them down right. 1, 2, and -1. And the second matrix is 2, 0, and 1. And 2, -1, and 3. And the last one, 4, 1, and 2. Isn't this cool? Have a calculator do this for you. And you can click calculate, but it's already done. There's the answer right there. Use matrices to solve number 9. Oh, you would know how to do number 8, wouldn't you? You'd add A and B together and then take the answer times itself. That's what squared means. So what would A and B equal if you add them together? 0, 1, and 1. See what I'm doing? And then after you get your answer, you take that times itself. That's what squared means. So number 9, use matrices to solve the systems. Well, now I have to go back and find something else up here. What am I looking for? I'm looking for matrix algebra calculator. See what that gets me. Gets me a whole bunch of stuff, but I want the one that comes with easycalculation.com. Matrix Algebra Calculator. I guess both of these. 3 by 3.
That's not the right one.
Oh, that's not the right one, is it? Let's go back. What did I do? Is it going to let me go back? Nope.
Just click on
Matrix. Algebra calculator. Well, it's not doing it, is it? There. Solve algebra linear problems. Yeah, that was multiply. That's one where we just were. Solve algebra linear problems. So we come down here and we go solving. And what do we put in here? We have x, y, and z for number 9, right? What is x?
1.
What is y?
3.
3.
Or is it 0?
And what is z?
On number 9.
Yeah, the first row, number 9. There is no z, right?
Mm-hmm.
So what would z be?
0.
0. And what does it equal?
The first row.
19.
19. Let's go to the second row. What's x?
1.
Oh,
Oh, well, like there's no x.
so x is,
0.
yeah, you better write yourself a note on that one, hadn't you? What is y?
1.
Thank
Wait,
you.
why is it 0 again?
Are you looking at the second row?
Oh.
Or are you looking at the first row again?
That's, no, I see what you mean.
Write yourself a note. X is 0. Y is 1. What's z?
On the second row is 10.
10 for z?
Sorry, 3.
Whoa, I'm telling you, you girls are going to be in trouble when it's test time, aren't you?
Oh.
And what's the answer?
10.
10. Third row. What's x?
3.
See how they mix it up on you? What's
How do
y?
you do this?
0.
0. What's z?
1.
And you can be assured the guy's going to mix it up on you on the test.
Why is it mixed up?
To mess with your head, to see if you understand math or if you're just taking numbers off the page and sticking them up there. They're testing to see if you understand or if you're just picking numbers and throwing them on the paper.
That's -5 right there.
-5. Calculate. Did it already do it? What are the answers?
-2, 7, and 1.
-2, 7, and 1. Well, that was cool enough, wasn't it? All right. Let's do something else. That's the thing about this test. You just keep going from one thing to the other. All right. On counting money in her piggy bank, Sally found that she had 122 coins. So nickels plus dimes plus quarters equals 122. Agreed?
Mm-hmm.
The total value of the coins was $15. So that means 5N plus 10D plus 25Q equals what? $1,500. I'll just put it in cents, okay? 1,500 cents. Everybody see where I'm getting my numbers?
No.
And the value of the quarters, that would be 25Q. That's the value of the quarters, right? What's it say? Was, that would be equals what? 4 times the value of what? 4 times the total value of the nickels. That would be 5N, wouldn't it? Are we looking at the same paragraph there?
Yeah.
Where did you get the 122?
Read the first sentence.
Okay.
Sally found that she had what?
122.
122
Coins.
coins. So that just means I take the coins plus the coins plus the coins, I get 122. Then when she talks about the money, then that's money is 5 times a nickel, and 10 times a dime, and 25 times a quarter. So that's where the 1,500 comes from. And then 25 times the quarters, that's how much money she has in quarters, equals 4 times how much money she has in nickels. And when you're teaching this to little kids, counting coins and then translating in their head to money, you're going to pull your hair out trying to get them to keep that straight. And they're going to agonize over this stuff, and you just take some M&Ms. Make it taste better. How many of each kind did she have? So, what do I have here? I have another one of these things to solve. So we go reset. And what do I put in here? I look at the board. What do I put? What's in front of N?
5.
Can you turn on the projector so we can see the
Oh, yeah.
Okay.
Thank you. Sorry about that. What do I put? What's in front of N on the first sentence? 5.
Oh.
First row?
I don't
One.
know what.
This
Right.
first row.
Aha! 1.
We have 1, 2, 3 rows.
Oh my goodness.
So what goes on the first row? 1. And then what? 1. And 1. And what? 1, 22. See? You see where it said, what? My heart just can't wrap itself around this stuff.
The heart is deceitful and desperately wicked.
You're not wrong.
Good for you. What's on the second row?
5.
5. And then what?
10.
10. And then what?
25.
25. And then what?
1500.
1,500. What's on the third row?
25.
Wait, but that's the
Wait.
quarter.
We can't let this confuse us.
What's 4 times 5?
Good job, Celeste.
What's 4 times 5?
24 times.
So we have nickels first. Oh, wait a minute. We better fix this, hadn't we? So this needs to be 20N minus 25Q equals 0.
Wait, why is it minus 25?
Because I want the letters on this side and the numbers over here.
Oh.
So I want all my variables on one side. So I have 20N minus 25Q. And you say, why didn't you say 25Q minus 20N? Because I've got NDQ, NDQ. So I'm going to do NDQ again.
Mm-hmm.
So what's N on the third row?
25. Isn't it? Oh, just 20.
Just 20. You
I'd already
you
written down
ladies are
25.
wearing me out. What's D?
0.
Oh, beautiful.
Good
Thank
job,
you.
Celeste.
Good job. What's Q?
25.
Negative 25.
Negative 25. Negative
We can
25.
math. Not today, okay.
Oh, I think it wants you to do the.
And what's the last one?
Wait.
Oh, it wants you to change the plus in between the X and
Yeah, because when I put them in a row like this.
yeah, no, it
No,
wants
on
you to
the-
change on the thing the
Oh, it did?
plus to a minus instead of putting a negative 25. Does that make sense?
Yeah.
Oh,
So now what do I have to
You
put?
write.
Put 25 and then.
I have to go
Click
Yeah.
that.
Yeah.
You click
Negative.
the and then
25.
I wish I didn't do that.
I know. I wish that.
That's just
Yeah. And then what goes here?
0.
Good. And what do I get for an answer? I have what? 40 nickels, 50 dimes, and 32 quarters. Is this cool?
I love it.
Why is the total? I thought the total value of the quarters was 4 times the value of the nickels.
Okay, so that means I got 20 nickels, right?
Right.
How many nickels? How many nickels in the answer?
40.
What's 20 times 40?
2.
20 times
Oh,
40.
80.
Oh.
I got 40 nickels. So, 40 nickels. I'm sorry, 40 nickels. So a nickel is worth 5 cents. So how much money do I have in nickels?
Oh, I see what you mean. The value, not the number. Yes.
Yeah.
Okay, I get it.
Okay.
Mm-hmm.
And I have how many quarters? 32. What's 32 times 25?
Uh, 70? Is that right?
No.
Hold on, Craig.
32. 32 times 25 equals $8. The number of quarters, $8, equals 4 times
4 times the total value of the nickel.
4 times the total value of the nickels. And the nickels are how much? 40 nickels? 40 times 5 is, that's $2. What did I do there? $0.25 times each quarter and 5 cents times each nickel.
So it's really good at like matrix multiplication because it'll remember that matrices. So if you have like a lot of problems with this matrices is really nice. But what I found on my phone that works is called wolframalpha.com, and it looks super strange and weird, but it does actually work.
Is that the answer in the book that what we have up there?
Augmented matrix REFF.
Which one is that?
Variables 3 equals. I don't know how to talk,
Number 10,
but I like bookmark it.
40, 50, and 32. We got the right answer.
What's it called? Matrix multiplication?
Yeah, this is the right answer.
$8 and
Augmented matrix.
how come? Oh yeah. We got 40 nickels, so we have $2 worth of nickels. What's 2 times 4?
8.
$8.
Yep.
Yeah. Okay.
We did get the right answer?
Yeah, we did.
Yeah.
Oh,
Did you hear what we just did?
thinking, what?
Did you hear what we just did?
Alright.
So we have 40 nickels, so 40 times 5 is $2. Right?
What?
we have $2 worth of nickels.
Yep.
4 times 2 is $8.
Yep.
And 25 times the quarters comes out to be $8. 32 times 25 is 8.
I see what you mean.
Okay?
So in our answer, do we need to say the value?
How many of each kind of coin?
How many, not the value.
Right. How many of each kind of coin?
I see. Cool.
So now look what they've done for problem 11.
There's a lot of problems in this practice.
Yeah, there are. And they just keep changing up on you too, don't they?
Yeah.
Problem 11 says, just come over here and write it down. Two, 1, 1, 1, 0, 3, 2, 4, and 0, 0, 1, 2. Find the solution. Solve. This is x, this is y, this is z, and that's the answer. So no x's, no y's. 1z equals 2. So what does z equal? 2. See what happened?
Do that again.
Do you see what happened?
No.
No x's, no y's. 1z equals 2. So since there's no x's and y's, I know that z equals this number. So I've already found one of them. You follow that?
Mm-hmm.
I suppose you could take the calculator and plug these numbers in, 2, 1, 1, 1, 0, 3, 2, 4, 0, 0, 1, 2, and get the answer. You could do that. You follow me? You're still solving. When it says solve, you're still using the same thing we just worked on. But I'm looking at this and going, wait a minute, z is 2. So if z is 2, then this is 0 times x plus 3 times y plus 2 times 2, 4, and that equals 4. Oh, 0 times x is 0. So now I have 3y plus 4 equals 4. So 3y equals 0. So that means y is 0. So now up here, I have 2x plus y plus z equals 1. And I already know that z is 2 and y is 0. So I have 2x plus 2 is 2. So minus 2, 2x is 0. So x is also 0.
My calculator showed that x was negative 0.5. But maybe I am.
Well, yeah, because I copied this down wrong. Because it says, watch, it doesn't equal 2, it equals 1. And then minus 2 and minus 2, I made a mistake, would be minus 1. Divide that by 2, and you have negative 1/2. What's negative 1/2? Negative 0.5. So that's what I get for doing it manually. I made a mistake.
You did a really good job. That's a
Use
lot
the
of math.
calculator. Skip 12 and skip 13.
Oh, yay.
Because you know what the answer is? No solution. So if there's no solution, why do they have you work a problem? This is frustrating enough without them doing that to you.
Exactly.
Okay. Number 16.
Oh.
Does 5 equal 2 in modulo 3? Modulo 3. What does modulo 3 look like? 0, 1, 2. Let's go 5. 1, 2, 3, 4, 5. Where'd I end up? I went around, I made 5 moves. 1, 2, 3, 4, 5. Where did I end up?
At 2.
So does 5 equal 2 in modulo 3?
True.
Yes. Does 9 equal 5 in modulo 4? So now I have to change my picture to a modulo 4. So that's 0, 1, 2,
Well,
1, 2.
nothing can equal 5 in modulo 4. There is no 5.
I know.
So
1,
that has to be false.
2,
Right?
3, 0, 1, 2, 3. What are we doing?
So nothing can equal 5.
Modulo 4. Okay, watch this. So let's go 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Where'd I end up?
At 1, which is not 5.
Now let's go 5. 1, 2, 3, 4, 5. Where'd I end up?
Wait, what?
What did you just do?
So
What
it's
is this?
true?
I just, okay, I went, let's go on the outside. 1, 2, 3, 4, 5. Where'd I end up?
So you go around each time. Oh.
Whatever that number is, you start at 0 and make that many moves around the module. And where you end up. So,
Oh, that's frustrating.
does 9 equal 5 in modulo 4?
True?
True. What did we just
It ends
do?
up at 1. I
That's
don't
true.
like it though.
Does a move of 9,
But now we know.
does a move of 9 equal a move of 5?
It does, yeah. I
A
understand.
move of 9 equals
Yeah,
1,
I
a move of 5 equals 1.
it just confused.
When will we need to use the clock arithmetic? Like,
What?
What's something that we would use the clock arithmetic for in real life?
When you're teaching little children clock arithmetic, you're preparing here. The only reason there's only 3 people in here instead of 25 is because you have to have this to be a math teacher. Because you have to teach a whole lot of this stupid stuff to little children. And you know what happens? Why little children come to me in college without a good background in math? Their teachers didn't take this class to learn how to be good math teachers. And the class that you take in the education department on how to teach arithmetic. But you're studying this because you're going to teach this to little kids. Okay? All right, where are we now? What's 3 plus 2 in modulo 5? What's 3 plus 2 in your head? 5. So what's
Which
5
is
in
0.
modulo 5?
0.
0. You follow how that works? What's 2 minus 4 in modulo 5? It'd be negative 2, right? In modulo 5, go back negative 2, and where are you? 4 and 3. From 0 back to 4 and 3. You're back to 3.
Which problem was that? I'm sorry.
17C. Do you want me to do 17B?
Yeah.
17B, 4 times 3. What's 4 times 3 in your head? 12. So that means you go around 5 and 5, 10. So the next move is 2. So the answer would be 2.
And which one do you start at? Do you start at 0 or 1?
You always start at 0.
You always, because remember in these modulos, they always have 0. If it's modulo, what? Modulo 4 is 0, 1, 2, 3. Modulo 5 is 0, 1, 2, 3, 4. Then 17D, what's 3 divided by 2 equals n? 3 divided by 2 equals n. Well, that means 3 equals 2 times some number, doesn't it? So how many moves of 2 would I make to get to 3? What is this, modulo 5? Is that what we're doing? Well, 2 times 1 is 2. 2 times 5 is 10. 2 times 10 is 20. Now 3 moves of 5. 1 move of 5.
It's 4.
Oh, let's just draw a modulo 5 and do it. Zero, 1, 2, 3, 4. 0, 1, 2, 3, 4. And I make a move of 2. If I follow that, then I make another move of 2. If I follow that, then I make another move of 2. If I follow that, then I make another move of 2. Aha! And there I am at 3. Now the question is, how many moves of 2 did I make? 1, 2, 3, 4. So 2 times 4 is 3.
Okay.
You like that one, Celeste?
No, I don't.
But you ended up on 2.
I ended up on
What's 2 times? No, we ended up on 3, didn't we? Made a move of 2, and here we are. Last time we landed on the 4th move. We landed at 3.
So why'd you write a 4 by the 2?
because it's on the
Because
line.
what's 2 times 4? In your head, what's 2 times 4? 8. What would 8 be in modulo 5? 3. So I just started making moves of 2, till I arrived at 3, and then counted how many moves I made to get there. Maybe you could do this. In your head, 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 8. That would give me 3 for an answer.
Can't we go like, say that, well, I guess you'd have to guess, but.
You know what else you could do? You could make a table for modulo 5 of multiplication facts.
Yeah, there's one actually, we have it in our handout.
Well, if you have it on your handout, then you can bring it with you. And what number would you take times 2, look at 2, and go over till you find 3 for the answer, and what number was it?
1.
What?
Wait.
On
No,
your
it.
modulo 5 multiplication, or are you looking at addition?
Multiplication.
It's 4.
Where?
Wait, 2 times what number equals 3?
2 times what number gives you an answer of 3?
1.
4. See, 2 times what
Sure.
number equals 3? And it's
Are you guys looking at the same chart?
Oh.
Oh, we got
feels
it?
reversed to what it should be.
Because you have to look for the other number instead of that number.
Mhm.
I see.
Okay, skip 18 and 19, and let's go to 20. Use the table to find the results of each of the following operations. What's dollar star cent? Dollar. Down the left, I'm looking at dollar.
It's
Across the top, I'm
number
looking at
sign.
cents. And what's the answer?
I love abstraction.
What you
Wait.
get?
Whoa, it's dollars?
Hashtag. Is that right?
Hashtag, yeah.
Now, what's
Hashtag times hashtag?
Hashtag.
Hashtag. I love abstraction.
so now? I got hashtag down the left. Then I go asterisk,
Equals
hashtag again. And what do I get?
hashtag.
Hashtag. So you do the parentheses first, then you do the second operation with that answer.
Yeah.
Okay.
Times hashtag.
Number 21. Is the set hashtag, dollar, percent, and cent closed with respect to the operation asterisk? Got your notes there? What's closed mean? When you operate, do you always get one of those four elements? Hashtag,
Yeah.
dollar, percent, or cent?
Yes.
So is it closed?
Yeah.
Closed means you get one of those numbers, so you say yes. Is the operation commutative? What's commutative mean?
That you can, that like A times B equals B times A.
Yeah. And find the identity element if there is one. So look across the top. What operation leaves them in that exact same order?
Hashtag.
So what's your identity element?
Hashtag.
Hashtag. Then find the inverse of each of the following.
We're basically just trying to see if this is a group, right?
Yeah, but they're not asking that yet, are they?
No.
No. So, you know how to find the inverse? What's the identity element?
Asterisk.
If the identity element is hashtag,
Did I just say asterisk?
identity element is hashtag. Then you go, what's the inverse of hashtag? Star what equals hashtag. So I go hashtag star what equals hashtag. And what gives me an answer of hashtag? Hashtag. So there's the inverse. Let's look at the next one. Dollar star what equals hashtag. So I go down the left to dollar, and I go over till I find hashtag for an answer. And what's did I operate on? What was the operation that gave me hashtag for an answer?
Why do you want it to be hashtag?
Because hashtag is the identity element.
Oh, because you just figured.
See the inverse,
Right.
a number, operation, inverse equals identity element. So let's do that one again. You go down the left to dollar, across till you find hashtag for an answer, up to the top, and what's the multiplier? Or what's the operator?
Cent.
Cent. So cent is the inverse of dollar. You follow that?
Mm-hmm.
For percent, go down the left to percent, across till you find an answer of hashtag, and what did you use to operate on it? Percent, okay? Number 25 is more of the same. Find the identity element. What's the identity element for number 25? The picture there with at as the operation.
And
Yep. does any element have an inverse? And so what you ask is, can I take something down the left at something and get and for an answer? Yep, in all three cases. Is the operation commutative? Is S at hashtag, what's S at hashtag? I mean, dollar at hashtag is dollar. Is hashtag at dollar dollar?
No.
No. So what do you conclude?
Not commutative.
That it's not commutative. Okay, last question. You stop when you get at the bottom of 661. We're not going to do the next page. We're running out of time.
Do we need to do it on our own though?
No.
Okay.
Just stop when you get through with 26. So S means select the second number, and L means select the lesser of the two. Is S distributive over L? What they just said is does A S parentheses BLC is that distributed? Does that equal A S B L A S C? So just put numbers in there. 1, 2, 3. B 2L3. What do you choose?
2.
2. 1 S2. What do you choose? 1, right? The smaller? Is that what S means? Take the smaller?
No, S means to take the second.
Oh, the second. 1S2 would be 2. So 1S, 1, 2, 1, 3. 1S2 says take 2. 2. 1S3 says take 3. 2L3 says take
2.
what? The larger?
Yeah.
3. So is it distributive?
Oh, no.
Nope. Is L distributive over S? Then you just come over here and write is L distributive AL over BSC? And that would be asking, is ALB SALC? Am I going to get the same answer for both of these problems? And just put numbers in there. 1, 2, 3, 1, 2, 1, 3, and see what happens. You follow me? Just pick some numbers and put them in there so it helps you make sense out of that abstract stuff. Okay? That's it. That's all of the test. Oh, bring your notes, bring your practice test.
So the test is
Bring
on
your-
Tuesday?
Bring your little easycalculation.com and you are in business.